Example: use the triangles below and the definitions of the 6 trigonometric functions to complete the table. So here is where we want to use our special right triangles, a 30, 60, 90 triangle and a 45, 45, 90 triangle, in order to evaluate the 6 trigonometric functions at 30 degrees, 45 degrees, and 60 degrees. So we know for the trigonometric functions that the inputs are angles and the output is the value of a ratio. So we're going to use that here to complete the table. Okay, so let's first find the missing side lengths in these 2 right triangles before we go to try to complete the table. I'm going to start with the given 30, 60, 90 degree triangle where the short side has a length of 1/2. We know that we can double that value in order to get the value of the hypotenuse, which is just 1, and multiply by √3 to get the value of the long side. From here, I move on to the 45, 45, 90 degree triangle that's given. It's given a hypotenuse of 1. So how do we get to that short side? Well, to the short side, I want to divide by √2. 1 divided by √2 is the same as √2 over 2, just by rationalizing the denominator. So I'm going to call this side √2 over 2 and this side √2 over 2. So now I'm all set to complete my table. Now again, I want to write somewhere to remember. I got so, ka, toa, and I don't want to forget it. Okay, so let's start with my 30 degrees here. So if I'm at 30 degrees, then I would call my 1/2 opposite side. I would call, so again, think about where you're standing. You're standing up here by the 30 degrees. 1/2 is the opposite side. Let's see, the √3 over 2 is the adjacent. And of course, the hypotenuse is always the hypotenuse, and that part doesn't change. So given that, I think I'm ready to complete the first row here of the table, all of these values. All right, so if I go to do that, then I'm going to have the sign is the opposite over hypotenuse. So opposite is 1/2 and hypotenuse is 1. So 1/2 divided by 1 is 1/2. For cosine, I have adjacent over hypotenuse, or √3 over 2 over 1, which of course is just √3 over 2. For tangent, I have opposite over adjacent, so that gives me 1/2 over √3 over 2. So let's see, I'll do that on the side here. 1/2 divided by √3 over 2 is the same as 2 over √3. That gives me 1 over √3, which, rationalizing the denominator, gives me √3 over 3. So √3 over 3 goes down here. Now, I like to use the reciprocal identities, and I have like a little errant thing here. I like to use the reciprocal identities in order to find the value for cosecant of 30 degrees, secant of 30 degrees, and cotangent of 30 degrees. So in order to do that, I just take, for cosecant, I'm going to take, so like think about how these are related, right? These are the reciprocals. Okay, so for cosecant of 30 degrees, I take sine of 30 degrees and flip it, right? Find the reciprocal. For secant, I'm going to take the cosine value and do 2 over √3. Rationalizing the denominator gives me 2 √3 over 3. And for cotan, I get 3 over √3 to flip that. But again, rationalizing that denominator is just going to give me √3. Okay, now let's go and be a little bug at the 60 degree angle to fill out this bottom row here. Okay, so if I want to fill out that bottom row here, then I'm going to pretend I'm this little bug here standing at the 60 degree angle. If I want to do that, I need to relabel my adjacent and opposite sides, because now I have a different view of things. So from this 60 degree, looking opposite, right? Think of the opposite side as the one that the angle opens up to, right? It opens up to this side over here. So I need to now call this the opposite side. And then the one that's just next to, right here, that's not the hypotenuse, is going to be called the adjacent. All right, so now I'm ready to complete my 60 degrees. So sine of 60 degrees is opposite over hypotenuse, so √3 over 2. Cosine of 60 degrees will be adjacent over hypotenuse, or 1/2 over 1. Tangent will be, of course, opposite over adjacent. So root 3 over 2. So this is one where I kind of need a little side work here. Root 3 over 2 divided by 1/2 is the same as multiplying. That just gives me a root 3. Great, root 3. Okay, and now I just use those reciprocal identities, which means the cosecant of 60 degrees is just 1 over sine of 60 degrees, which really just means flip each of these fractions, right? So 2 over root 3, and I know that's the same as 2 root 3 over 3. Flipping 1/2 gives me 2, and flipping root 3 gives me 1 over root 3, but I know that I can just rationalize the denominator to get root 3 over 3. All right, now we're finally ready for this 45-degree angle. So if I want to do that, then I'm over here on my 45, 45, 90 triangle, and it doesn't matter which angle I stand at because of the symmetry there. So let's say I'm standing in the bottom right corner here, and I want to label my sides accordingly. So once I'm standing down there, this is the opposite. The side next to it is adjacent, and of course, the hypotenuse is always the hypotenuse. So from there, I have sine of 45 degrees is opposite over hypotenuse. So root 2 over 2 divided by 1 is just root 2 over 2. Same thing with cosine, adjacent over hypotenuse. So cosine of 45 degrees is root 2 over 2 over 1, which is just root 2 over 2. For tangent of 45 degrees, I have opposite over adjacent. So root 2 over 2 over root 2 over 2, right? I'm root 2 over 2 over root 2 over 2, but those are just the same values, so any number divided by itself is just 1. All right, now I get to my flipping, so this is just 2 over root 2, but what would that give me? Rationalizing the denominator gives me, let's see, 2 root 2 over 2, but that's just root 2. All right, for secant, I'm flipping the same thing, so I'm going to get the same thing, right, as my cosecant. And finally, cotan of 45 degrees is just flipping 1. 1 over 1 is just 1.